Now we're going to use GeoGebra. It's an application that can help us to graph and also to come up with the equation uh, to describe this graph. Okay, now first of all, you can go to this website, geogebra.org, and you just click download, and you can scroll down to find the version that is appropriate, on your computer. Actually, you can actually download an app on your smartphone or tablet. Okay, so after you download it, and then you can just start it. Okay, here's a startup screen of GeoGebra, and you can just go to the view and click a spreadsheet. And here you can actually see we actually don't need this view, so we just need the spreadsheet here. Okay, so we're gonna copy the data from the Excel to this GeoGebra. Okay, so let's go to Excel. So that's the data we prepared. So just select all the data and then just click copy, and then come back to GeoGebra, and then just paste. So you can just do Control V, or if it's on the map, it should be Apple. Okay, so all the data comes here. And then we're gonna draw two kind of graph. One is a position time graph. Okay, so for the position time graph, I'm just gonna select this area, right? So including both time and this position. So then I'm gonna click here and click the arrow. If you just one click, you're gonna do one variable analysis, but we're actually gonna analyze two variables. One is the time, one is the position. So I click this and choose two variable regression analysis. The regression actually means based on your graph. So this is the data, right? So if you click analyze, first of all, they're gonna draw a graph. So see, that's a nice graph. So the y coordinate is the position, x coordinate is the time. You can actually see. So the x is from A2 to A37. See, it's from A2, so this is A2 to all the way to A37, so that's the time. And then horizontal is B2 to B37. Of course, that's position, right? So this is just part of the job done. So we just graph it. So you can see a very nice part of the curve. It should be part of the parabola. And then the regression, we're gonna do the regression means based on the data, we're going to try to draw a best fit curve. In this case, we know the position versus time graph is supposed to be a quadratic function. Okay, so here you go. This is the equation to the displacement equals the initial velocity. So this is supposed to be initial velocity here. Initial velocity, just like the v0 here, initial velocity multiply time, then plus 1/2 at squared. So yes, the relation between the displacement or position, because we set the initial position as 0, so then the displacement is really just the position. So the position should be a function of t, and it's the time. It's actually quadratic function. Okay, so it is a quadratic function. So then let's come back to the GeoGebra, and then if we do regression means find the equation that can represent this graph. Okay, and since it's quadratic, so we can just choose from this list, because quadratic is the polynomial function when the highest degree equals 2. So it's quadratic. So you choose polynomial, and then you choose the degree, highest degree is 2, right? Okay, so that's we did. Okay, here you go, we got this function. The function is y equals 1.0783 x squared plus, and of course x here is actually time. The y here it should be the position. Okay, so I'm just gonna copy this equation to okay, I copied it here. So that's the equation using the regression analysis. And then, of course, the y is actually the displacement, the x is actually the time. Okay, if you compare these two equations, because the displacement is supposed to follow this, this formula. And then if you compare the two equations and just compare the coefficient of the t squared with the x squared here, and 1 over 2a is the coefficient, is supposed to equal to the 1.0783. And then I just from this equation I multiply 2 on both sides. I can figure out that the a is actually 2.1566 meter per second squared. So that's the acceleration I got from the graph. Okay, let's come back to figure out the other graph, the velocity versus time graph. Okay, so this time I'm gonna go back to the yeah, I can just close this window, and this time I'm gonna choose the velocity time graph. So again, I choose the select this area including all the time and the velocity. So this is the time, this is the velocity. A little thing I should have to point it out that all the data displayed here, they only show 2 decimal places. But don't worry, the data stored is still pretty precise. They have many digits. You can see that later. Okay, so again, we're gonna choose the two variable regression analysis. And this time, see, the data actually having more digital places than the one displayed here. Okay, so just click analyze. And this time it's actually gonna be we have to choose the linear. Okay, so if you choose linear, well, actually the data is not that nice. It's probably because the time interval is so small, and then if you didn't when you collect the data, if it's not accurate, you can see the data is actually scattered pretty much but it's still if you draw the best fit line, right? So the computer basically automatically draw the best fit line, and then it's a pretty good line that actually take care of the points, right? Okay, and it's supposed to be linear because the acceleration is constant, and then the velocity versus time graph is supposed to be a linear graph. Yeah, I need to point out one little detail about here. If you look at the the axis here, this is 0.4, this is 0.6, and then definitely the vertical axis here is not 0. So that's why if you look at the red, the graph is actually intersect at the position is actually equals 0.2888. That's actually the initial velocity when you start record all the position time at that t equals 0, time equals 0 moment. Actually we do have initial velocity. That's actually true because when I start recording that video, the glide is already in motion. It didn't start from rest. Okay, and then since this equation is supposed to be initial velocity plus at, and then the two 2.1477, it really should be the slope, which should be the acceleration. Okay, 2.1477, if we compare this number with the number we got earlier, that's pretty close, right? Okay, so basically that's all about how to use the GeoGebra to figure out the graph and figure out the acceleration.